Good afternoon. So the Australian water industry spends around $250 million every year on electricity charges. And our client, SA Water, is actually the second largest consumer among these water utilities, which is actually quite surprising because SA Water is not the second largest water utility in Australia. We're round about the fifth. But yet they're spending $86 million every year on electricity charges. So why is that? Well, really, it's our geography that's against us. So South Australia, it's almost 1 million square kilometres, so bigger than Texas, bigger than Alberta. There's about 1.7 million people who live here, but most of them live in our capital city of Adelaide. But it's pretty dry there, so we rely on water from the River Murray to top up our water supply. But that river, it's all the way over here. And in between, there are some mountains. I'm calling them mountains, you would probably call them like hills, but they're big enough. Water's heavy, we have to move it. We have to get it up over those mountains to our city. And these people all around the state, they'd also like some water. And so we have to get it to them. And so moving water over large distances, it's energy intensive and expensive. And just in general, the energy needs of a water utility, they can be big. We firstly have to source that water. So we have surface water, we have rivers and reservoirs. We've got to get it from there, pump it out, move it around. We've got groundwater, again, more pumping. And we've got desalination in South Australia, again, an energy-intensive water treatment process. Once we get it, we've got to move it to our water treatment plants and we have to treat it. Once it's there, we have to move it again into our distribution network, to our storages, pump it around, supply all of our customers across the state. Once they're done with it, we then have to collect it. Again, more transfer, more pumping, send it off to our wastewater treatment plants and treat it to such a quality that we can use it for irrigation schemes, recycled water schemes for customers, and also discharge it to the environment. So you can see this energy and water cycle, it's a lot of work. But in a system like this, it may be energy intensive, but there's also a lot of flexibility in a system like this, and therefore a lot of opportunity to do things differently. This is the Mount Bold Reservoir. It's actually 15, 20 minutes from my house, and look at it. It's lovely and green and lush and full of water, but it's actually not always like this. So this is one of these reservoirs that we actually have to pump water from the river to top up every year so that we have water supply for Adelaide. And this is just one of many reservoirs around the Adelaide Hills and is the state that we need to supply water from every year. I mentioned before $86 million. It's actually quite a high percentage of the annual operating expense for our water utility. And we look at where that energy is being used. It's in that water transmission piece, that pumping from the river to these reservoirs, and in the wastewater treatment processes as well. So the good thing is, these are the systems that actually have the most operational flexibility. So if you're going to look for areas to save money, you'd want to be looking at these two things. And I think with energy prices only increasing, something needs to be done, and something needed to be done in South Australia about, the amount of energy we're using and the cost of that. So SA Water did something about this. They've had this Zero Cost Energy Future program, which is actually 7 different initiatives. A big component of that has actually been investment in renewable energy assets. They've spent $300 million on solar panels and batteries spread across 33 different sites across South Australia. So that's really put, that energy piece into SA Water's hand. Another key component is this demand response. So SA Water actually operates their network on the electricity spot market. So that means the price can be $10,000 per megawatt hour or minus $1,000 per megawatt hour. You could actually get paid to pump. And so that gives, you've got operational flexibility in your water network, you've got variable prices. Pick the times you want to operate, save yourself some money. But the piece that I'm interested in, and the piece that Stantec has been involved in, is that piece in the middle there, that predictive optimization scheduling piece. It's really the data and the technology that's going to bring it all together to help people make better decisions and make the use of all these renewable assets in the network and make best use of operating on the spot market. Because really, sometimes it's not about how much energy you're using, it's when you're using it and when you're generating it. That's where you're going to make your savings. So if we have a bit of a look at the overall time frame of this program, SA Water's actually been operating on the spot market since about 2015, right? So got rid of your on-peak, off-peak tariffs from the energy retailer. Straight, we're going to operate on that spot market. And that saved them about $3 million a year. But from there, it can still be hot, it can still be dry. Your flexibility goes away. You still have to supply water to your customers. Underneath that, we've got biogas from our wastewater treatment plant. So we're able to generate that, generate electricity, sell that back to the market, create some revenue. But the real step change came in 2020. Basically, all of these renewable assets start coming online. We're generating energy. We can sell that back to the market, make some money. We can use that energy on site and offset the energy use that we're actually drawing from the grid. And then the last piece, to really drive it down to this zero cost kind of piece, you need to optimise your operating schedules. How are you going to run your network better? So now there's a need to co-optimise your water and energy objectives together. And so to do that, we needed to build models. So we built optimisation models that basically describe each of those major pumping type of systems. You know, your pumps to storage, where your customer demands are, what kind of transfers you need at the end of the network to supply downstream to Adelaide and beyond, as well as where are your solar assets, where are your batteries, where are your connections to the grid. A lot of data needed to run a model like this, and it can get quite complex. But the people who need to make scheduling decisions, they're system controllers and operators in a control room. They're not interested in models like this at all. So we needed a tool for them. So we basically built this tool called Production Scheduler, and it's a platform for network operators to plan and optimise their pumping schedules and wastewater biogas operation schedules every day. And so it basically brings together all the data that you need to run your model in real time, so current conditions, forecast conditions. It lets you press a button, send it off to your model, optimise your schedule, and bring it back so they can review it, interact with it, tweak that schedule, see what the changes happen in cost, see what the performance of the water assets are. Save that. Go and schedule that in the network. Hand it over to the next operator at the change of shift. Switch from one system to the next with one consistent platform. I don't know what happened to my map there, a bit squished. But because data-driven decision-making, it really is about getting the right data in the right format at the right time for the people who are making that decision. And so all of these data inputs, we need to know a water demand forecast for the next 1, 2, 3 days. We need to bring that in live. We need to know what we're trying to produce at the end of our system. What does that water treatment plant down the end need? That's an input for our model. It needs to know how much to transfer. We need to know what the current volume in our storages are. That's got to come in live. What's the energy price? What's the market doing right now and for the next 1, 2, 3 days? That's our price forecast. We need to know what our solar assets are doing. What's the forecast energy generation at our solar? So we've got a solar forecast model as well. All of these models feed into that tool so that the operator can press a button, update it, review it, check it, make a change if they want, schedule their pumping. But sometimes it's not about having a fancy optimisation model or a nice user interface or data that's at your fingertips. It's really about user workflows. That's how they're going to use it. So a big part of our project as well was actually just working out how people wanted to use this tool and how they were going to use this tool. So number one, they still want to do manual scheduling. So we have to have features that let them interact with that schedule. We've got to be able to optimise these schedules, and it's got to be appropriate for that operational kind of setting. It can't take days to optimise. It's got to take 30 seconds. Otherwise, they're not going to use it. We've got different assets. We've got solar on some sites, not on others. So we need a tool that is actually expandable. As new models get built, we need to be able to connect those models, configure the assets that are relevant for those systems, and have the flexibility in the tool to do that. We want to optimise our wastewater treatment as well and the biogas generation. So we need all of the assets and components and the data inputs that are relevant for different types of system. Some are quite simple. Maybe we just want to run it on a schedule. Tick a box, it'll run every hour, update, produce a schedule so someone doesn't have to interact with it and press run every time. And then we want to do some optimisation benchmarking, so different data so we compare what we forecast with actuals, what we were planning to do, what we actually did. So SA Water, they've undertaken quite an ambitious project here, right? All in the hope of driving their energy costs down to zero. And data and decision support tools have been a key initiative as part of that. So my question is, what's in the pipeline for your organisation? Do you have data that you could be using to make better decisions? do you have assets that are quite flexible, that you could be running harder? Or do your people just need better access to data to make better decisions? So if the answer is probably to any of those questions, come and have a chat. Thank you very much.